Okay, hi guys. So in this lecture, we'll be discussing on Gibbs free energy or Gibbs energy. Gibbs free energy or Gibbs energy. Which is simply G. So G is a state function and an extensive property. And an extensive property. Okay, and we can write G would be equals to H minus Ts, and dG would be equals to dH minus d of Ts. So at constant temperature, we can write that dG would be equals to dH minus TdS. So integration of dG would be equals to integration of dH minus integration of TdS. So that would be dG equals to delta H would be equals to, rather delta G would be equals to delta H minus T delta S. Okay. Next, for chemical reactions at non-standard states, we can write that for chemical reactions at non-standard states, that delta Rg is equals to delta Rh minus T delta Rs. Okay, and for chemical reactions at standard states, we can write that, first let me complete this. For chemical reactions at standard states, we can write delta Rg naught would be equals to delta Rh naught minus T delta Rs naught. Okay, and we already know that delta Rh naught is equals to summation of gamma P, gamma of products or stoichiometric coefficients of products. Hm is the molar enthalpy of products minus summation of gamma R or stoichiometric coefficients of R into molar enthalpy of reactants. That can also be written as summation of gamma P delta HF products minus summation of gamma R delta H, this is HF reactants. Okay, so similarly, using this analogy which we have already seen in past few lectures, we can write, so similarly we can write that delta Rg naught is equals to summation of gamma P molar Gibbs energy of products minus summation of gamma R molar Gibbs energy of reactants. So delta Rg naught can be written as gamma P delta R of products minus sigma of gamma R, or sigma of stoichiometric of gamma R, which is the stoichiometric coefficient, multiplied with delta Rg naught of reactants. Okay, Now let us see what these terms are. So gm naught is standard molar Gibbs free energy. This is standard molar Gibbs free energy. Delta F G naught is standard Gibbs energy of formation. Okay, and delta R G naught is standard Gibbs energy of reaction. Okay, and now let's see what is delta F G naught. So delta F G naught is change in standard Gibbs free energy when 1 mole of substance is formed from its constituent elements. Those are stable in nature. So delta F G naught is change in standard Gibbs free energy when 1 mole of substance is formed from its constituents elements. Those are stable in nature. Okay, so example can be, suppose we have formation of H2OG from H2 and half O2, it forms H2OG. So in this case we know that delta RG naught can be written as delta formation G naught of H2OG minus delta F G naught of H2G minus delta F G naught of O2G, and these two terms would be 0. Why? Because those are found in the elemental form in the nature, hence delta F, the formation of Gibbs energy at standard state for H2 and O2 would be 0. Okay, so for elements, this is the same which we have already discussed for entropy and enthalpy as well. So for elements, delta G F naught would be equals to 0, delta F H naught would be equals to 0, and delta F S naught would be equals to 0, as they are thermodynamically more stable. Okay, and now let me write down a very important note, that for H plus aqueous we have enthalpy of entropy of formation, enthalpy of formation at standard state, delta G naught, delta F G naught, and delta SM naught, which is molar entropy at standard state, is 0. Okay, or in other words, if we have the formation of H plus ion from H2 gas plus electron, delta HF naught for this reaction is 0. Please remember this is a very important note. Okay, this has been assigned a 0 value, we have assumed it, and this is universal. Similarly, for delta F G naught, delta F H naught, Sm naught of H plus ion, H plus aqueous is been assigned, or rather has been assigned value equals to 0. So please remember this, these two are very important notes. So with this we come to the end of this lecture. In the next lecture we'll be seeing more on Gibbs free energy. So till then, good luck and goodbye.